Good morning, everybody. My name is Dr. Rajesh Kumar, Department of Chemistry, Ramdyalu Singh College, Muzaffarpur. Today, I am going to teach chemistry of carbohydrate. As you know, carbohydrate is the source of energy. It shows various biological activity. Carbohydrates, along with lipid, proteins, nucleic acids, and other compounds, are known as biomolecules. They serve as a form of stored chemical energy. They form part of the structure of some cell and tissue. Carbohydrate or saccharides is a Greek for sugar or polyhydroxyaldehyde or ketones or substance that yield such compounds on hydrolysis. This is the fructose, this is a glucose and beta D galactose. Carbohydrates include not only sugar but also the starch that we find in such as bread, pasta, and rice. The term carbohydrates comes from the observation that when you heat sugar, you get carbon and water. That is also called hydrate of carbon. Classification of carbohydrates. Carbohydrates are divided into different categories. First is the monosaccharides contain a single polyhydroxyaldehyde or ketone unit, that is glucose and fructose. Disaccharides consist of two monosaccharides unit linked together by a covalent bond, that is called the example is sucrose. Oligosaccharides contain 3 to 10 monosaccharides unit, that is raffinose. And last is the polysaccharides unit, that is contain very long chain of 100 to 1000 monosaccharides units. It may be either straight chain or branch chain. Now, stereochemistry of carbohydrate is very important because in carbohydrates, there are various chiral centers, many chiral centers present in carbohydrate group. That's why stereochemistry is very important for carbohydrate. To understand the stereochemistry of carbohydrate, first we look the glyceraldehyde. Glyceraldehyde is the simplest carbohydrate, exist in two isomeric form that are mirror image of each other. In glyceraldehyde, this is the aldehyde group, this is the hydroxyl group, this is the hydrogen, this is the carbon, and this is the CO2OH group. In chiral carbon, if hydroxyl group is on the right hand side, that is called diglyceraldehyde. If hydroxyl group is on the left hand side, this is called L-glyceraldehyde. This is the L-glyceraldehyde. These are two examples of diglyceraldehyde and L-glyceraldehyde. These are not mirror images of each other. Chirality. Chiral molecules are not superimposed to each other. Chiral, if carbon atom is attached with four different atom or group, that center is called asymmetric center. In chiral compound, which compound will be carbon if it does not have a absence of plane of symmetry, center of symmetry, or alternate axis of symmetry is present, that compound is called chiral compound. In carbohydrates contain more than one chiral group. So there are some examples that you can see in erythrose. In erythrose, there are two chiral center. This C2 and C3 carbon is the chiral center. In a ketonic sugar, you can see here there are two chiral center. In glucose, there are four chiral center. Carbohydrates can be represented in Fischer projection formula. Fischer projection formula is a very easy, is a two-dimensional representation. Now we can see here glyceraldehyde. There are two planes. One is vertical plane and another is horizontal plane. In horizontal plane, with hydroxyl group is on right hand side. That is called diglyceraldehyde. In horizontal plane, hydroxyl group is on left hand side. That is called L-glyceraldehyde. In a top, aldehyde group is present, but in bottom carbon, CH2OH group is present. Naming of stereoisomers. Now we can see here, and when there is more than one chiral center in a carbohydrate, look at the chiral carbon farthest from the carbonyl group. If the hydroxyl group points to the right, when the carbonyl group is up, it is the D isomer. When the hydroxyl group points to the left, it is L isomer. This is the L erythrose and this is the D erythrose. The classification of monosaccharides. Monosaccharides are divided into different categories. If 3 carbons are present, it is called triose, 4 carbon tetrose, 5 carbon pentose, and 6 carbon hexose. The presence of aldehyde is indicated by the prefix aldo and ketone by the prefix keto. Now there is the glucose. This is the in glucose there is aldehyde group that is called aldohexose. In ketone there is the ketonic group that is called ketopentose. A family of D-aldose. We can see here, this is a D-erythrose and this is the D-threose, because in this case hydroxyl in erythrose hydroxyl group is on the right hand side. This is called D-erythrose. In threose this hydroxyl group is C3 carbon hydroxyl group is present on the right hand side. That is called D-threose. These are some examples of aldopentose. In you can see here, this is a C4 carbon at the hydroxyl group is left hand side. This is called L-ribose, and the C4 in C4 carbon hydroxyl group is on the left hand side. This L-arabinose, D-ribose, D-arabinose, D-lysose, D-xylose, D-lysose, and L-xylose. This is the family of D-aldose. This is a 6 carbon. D-allose, D-maltose, D-glucose, D-mannose, D-glucose, D-iodose, D-galactose, and D-tylose. Glyceraldehyde. We can summarize in the one slide. This is the erythrose. This is the threose. Further, we extend the carbon chain. This is the D-ribose, D-arabinose, D-xylose, D-lysose. Then and further extend into 6 carbon. This is allose, electrose, glucose, mannose, glucose, iodose, galactose, tylose. Now, family of D-ketose. D-ketose means ketonic group is present. Now we can see here in hydroxyl group in C3 carbon hydroxyl group is on the right hand side. This is called D-erythrulose. This is D-ribulose, D-xylulose. The chemical properties of monosaccharides. The monosaccharides do not exist usually in open chain form. It exists in cyclic form. And there are two forms of isomeric form. This is the beta D glucose and this is the alpha D glucose. In beta D glucose, C1 carbon atom in hydroxyl group is upside, this is called beta. If in a downside, this is called alpha. And this is the 6 member, this is called pyranose form. Now this is the Haworth representation of glucose. This is the beta D glucose and this is the alpha D glucose. And this C1 carbon is also called anomeric carbon. Now, fructose anomos. Fructose is a 5-member heterocyclic compound. Fructose exists in two forms also, alpha hydroxy, alpha D fructose and beta D fructose. In beta D fructose, hydroxy in C1 carbon atom hydroxyl group is on the top side, and in alpha D fructose, hydroxyl group is on the bottom side. Drawing furanose and pyranose ring. Now we can see here, this is a furanose ring and this is the pyranose. In pyranose ring, in C4 carbon hydroxyl group is on top side, and in pyranose ring, C5 carbon hydroxyl C2H group in the top side. This is called D. Now we can see here beta D ribose, beta deoxyribose, beta D galactose. This is beta because in C1 carbon hydroxyl group is top, and this is D because C4 carbon C2H group is on the top side. This is called beta D ribose and this is called beta deoxyribose. Why it is called beta deoxyribose? Because in 2 carbon, carbon number 2, there is no hydroxyl group. That's why it's called deoxyribose. In DNA, in deoxynucleic acid, deoxyribose is present, but in ribose nucleic acid, ribose sugar is present. Thank you. First of all, I'd like to thank UGC MMTTC Kumai University Nainital Director Professor Debra Joshi ma'am and course coordinator Dr. Chitra Pandey ma'am, who give me an opportunity to come here and participate in refresher course in chemistry. Thank you. Thank you to all.